Paramanand Ashok Pawar, working as an assistant professor in electrical engineering department, NB Navale, Sinhagad College of Engineering, Solapur. I have completed my MTech in power system. Now I am having the total teaching experience of 8 years. Today we are solving the problems on GMF equation of a alternator. So as we know that if J is there in a relative motion between conductor and flux, the EMF is get induced in a conductor. So this is the working principle of the alternator. So as we know that the fundamental EMF equation of the alternator is that is generated EMF is equal to 4.44 kp kd f phi t. So in that particular equation, kp is a pitch factor, kd is a distribution factor, f is a frequency, phi is a flux, and t is a number of turns. So on the basis of that particular equation, we are solving one example which is previously asked in a university examination. So will start to solve the problem on the EMF equation. So the stator of 3-phase 16-pole alternator has 144 slots. There are 4 conductors per slot connected in series. If speed of alternator is 375 rpm, calculate EMF induced per phase. So in the given problem, the resultant flux, that is phi, is equal to 5 into 10 raised to minus 2 Webers, that is 5 milliweber, and the coil span is 150 degree G electrical. Similarly, find the frequency. So the problem is very simple, because in the given problem, the stator of 3-phase 16-pole alternator has a 144 slots. There are conductors, 4 conductors per slot connected in series. Speed is 375 rpm, and calculate what we want to find out the value of EMF induced per phase. And in given problem, we have the value of the flux, that is 5 into 10 raised to minus 2 Webers, and the coil span is 150 degree electrical. The another thing is that we want to calculate what should be the value of the frequency. So for that solving of this problem, we want to know the fundamental equation, that is means EMF equation of alternator, that is 4.44 kc kd f phi t. So in the given problem, we have the value of flux, we want to find out the value of frequency, we want to find out the value of t, because as we know that t is a number of turns. So in given problem, this problem has a coil span is 150 degree. So as we know that, first of all, we want to find out the value of kp as well as kd, because as we know that the EMF equation has the value, that is 4.44 kp. So we want to find out the value of kp, we want to find out the value of kd, then f, that we want to find out the value of f, then the next term is flux. In the given problem, the flux is available with us, and next thing to find out the value of t, where t is the number of turns. These number of turns are calculated from the number of conductors which is given in the problem. So will start to solve this problem step by step. So first thing, that we want to find out the value of kp or kc, because as we know that the pitch factor is also called as a coil factor. So the formula is represented by either kp or kc. So the fundamental formula of kc is cos alpha by 2. But in given problem, the coil span is given, that is 150 degree. So for finding out the value of alpha that we want to take, that is coil span is equal to 180 minus coil span. So the value of alpha is given by the 30 degree. So substitute this value into that equation, we'll get the value of Kc or Kp. So the Kc is equal to cos alpha by 2. So it will be give you the value of Kc or Kp, that is 0.966. So the first term in that particular formula, that is the value of Kp or Kc, is available with us. So the next step to find out the value of Kd, and as we know that the fundamental formula of Kd is that Kd is equal to sine m beta by 2 divided by m sine beta by 2. So for that point of view, we know the value of m, we know the value of beta. So first that we want to find out the value of n, and what is the value of n? That is slots per pole. So in this that particular problem, the value of slots are given with us, that is 144 slots, and we know the value of pole. So we'll give the value of n, and the value of n is 9, because as we know that for finding out the value of m, we want to know the value of n, that is slots per pole. So m is equal to number of slots per pole per phase. So from that particular thing, we'll get the value of m, that is 9 by 3, that is the value of m. So we'll get the value of m. So next that we want to find out the value of slot angle. So for understanding of slot angle, as we know that for the slot angle, that is beta is equal to 180 degree divided by the slots per pole. So in that particular problem, that is slots per pole is a 9. So we'll get the value of beta. So that is the value of beta equal to 20 degree. So if you know the value of m and beta, substitute this value into the equation, that is Kd, will get the value of Kd. So substitute the value of m and beta into that equation, we will give the value, that is Kd is equal to 0.96. So this is the second term in the EMF equation of alternator. So the next step is to find out the value of the frequency. So the value of frequency is calculated by the fundamental formula, that is n is equal to 120f upon p. So in the given problem, the speed is available with us and we know the value of pole, then it will be easy to find out the value of the frequency. So in the given problem, the speed is given, that is 375 rpm. So the 375 rpm into, that is number of poles are 60. So multiply with this term and we'll get the value of frequency, and the value of frequency is a 50 hertz. So we know the fundamental basic values of Kp, Kd and frequency. Then the next term that we want to find out the value of T, and so for finding out the value of T, we have the number of slots per phase, because we want to find out the EMF induced per phase value, because in the given problem is asked to you, that is calculate EMF induced per phase. So for sake of that, number of slots per phase. So in the given problem, number of slots are available with us. So that is value 144, and this is a 3-phase alternator. So it will be give you, that is 48 value. So the number of slots per phase is given by the value, that is 48. So for finding out the number of conductors per phase, so multiply these 48 terms with the 4, because as we know that there are 4 conductors per slot. So multiply number of slots per the number of slots per phase with the help of number of conductors, that is 4. That will be give you the total number of conductors, and the total number of conductors per phase is equal to Z is equal to 192. So we know the fundamental formula, that is number of conductors, that is Z is equal to 2 into T. So we have the value of Z and we want to find out the value of T. So the T is equal to Z by 2. So we have the value of Z, that is 192 divided by 2. So it will give you the value of t, and that the value of t is equal to 96. So substitute this all value into that particular equation, that is the EMF generated per phase, that is 4.44, means as we know that 4 into 1.1, that is kf value is 1.1. So 4.44 into kp into kd into f into phi into t. So we know the value of kp or kc, that is 0.966. We know the value of kd that we had already uh, calculated from the fundamental equation. We know the value of frequency that we had already calculated. We have the value of flux, that is 5 into 10 raised to minus 2. So substitute that value, that equation will get the value of phi. And now before that, we have already calculated the value of t. The value of t is equal to 96. So substituting all these value into that equation will get the value of EMF generated per phase, and this value is 988 volt. So this will be the very simple problem based on EMF equation of alternator. So for understanding of this problem, everyone should understand the basic fundamental formula of a EMF equation of alternator, and that particular formula is 4.44. Sometime it is 4 into kf. The value of kf is 1.1 into kp, or that is called as pitch factor, or kc, that is called as coil factor, into kd. The value of kd is called as distribution factor, into f is the frequency, phi is the flux, and t is equal to the number of turns. So if we are having these terms, then it will be easy to solve the or the calculate the value of EMF induced in a alternator. So this is the problem which is based on the EMF induced in a alternator. Thank you very much.